Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discussion about metrology, and in that metrology related to quality inspection, and in that quality different type of gauges, instrument, equipment are uses. So let's discuss about that. So what is metrology? So metrology is a branch of science which deals with the study of measurement and study of measurement and measuring instrument. So metrology is the branch of science which deals with the study of measurement and measuring instrument. It helps to proper shape and size, required accuracy, minimum cost to reduce manpower, material wastage, reworking cost. Then what is physical quantity? Let's discuss about that. What is physical quantity? Those who are quantified or mapipariba that is measured using number is called physical quantity. Those who are quantified or that is measuring with number is called physical quantity. Example: length, mass, temperature, hardness, density, velocity. That is physical quantity. Units: all physical quantities are measured with respect to standard magnitude. That standards are called units. All measuring quantities, all physical quantity are measured with respect to standard magnitude. These standards are called units. So all physical quantity are measured with respect to standard magnitude. These standards are called units. So types of physical quantity. So types of physical quantity. One is fundamental quantity, another one is derived quantity. So types of physical quantity. One is fundamental quantity, another one is derived quantity. So types of units. So types of units. So fundamental units, derived units. So let's discuss about that. So fundamental quantities. Those physical quantity are completely independent and don't depend for other quantity for their measurement. So that is called fundamental quantity. So seven types of fundamental quantities are: one is length, meter; mass, kilogram; time, second; temperature, Kelvin; electric current, ampere; luminous intensity, candela; amount of substance, mole. Derived quantity. It depends upon the fundamental quantity for their measurement. Example: area, length with width; volume, length width, and height. That is derived quantity. So let's discussion about that. Systems of unit. So FPS, foot pound system. So systems of unit, foot pound second. So foot pound second. It is MK system, meter kilogram second. CGS system, centimeter kilogram second. MKS, meter kilogram second. CGS, centimeter gram second. SI, international system. Not all fundamental units are SI units. All fundamental units are SI units. So unit conversion. In simple example, you understand about that. King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. So King means kg, Henry means hg, hectogram, died means dg, decagram, by means base, drinking means D, decimeter, chocolate means C, centimeter, milk means millimeter. So C, that is the kg, hg, dg, base, dm, cm, mm. So let's see that is the unit conversion. So one more unit conversion between units and length. So 1 kilometer, 1000 meter, 1 km, 1000 meter, 1 meter, 100 centimeter, 1 centimeter 10 millimeter, 1 centimeter 10 millimeter. So 3 km 3000 meter, 2m 200 centimeter, 4 centimeter 40 mm, 4 centimeter 40 mm, 6 km 6000 meter, 0.5 meter 550 centimeter. So 40 cm 400 millimeter. So 5000 meter 5 kilometer, 400 centimeter 400 centimeter 4 meter. So 400 centimeter 4 meter. 80 millimeter 8 centimeter, 80 millimeter 8 centimeter, 2.5 km 2500 meter, 1 meter 1000 millimeter, 9000 millimeter 9 millimeter. So 0.10 so metric standard conversion, 1 millimeter, 1 metric standard conversion, 1 mm 0.0393 inch, 1 centimeter 0.9370 inch, 1 meter 39.70 inch, 1 meter 1 inch. So 1 inch is standard metric conversion. 1 inch is 2.54 centimeter. 1 inch 2.54 centimeter. 1 foot 30.48 centimeter. 1 yard 98.44 centimeter. So note 1 feet 12 inch. 1 yard 3 feet. 1 yard 336 inch. 1 meter. Unit time of conversion 1 minute, 1 minute 60 seconds, 1 hour 60 minutes, 1 day 24 hours, 1 week 7 days, 1 year 12 months, 1 year 52 weeks, 1 year 52 weeks. Unit conversion 1 millimeter, 1 millimeter, how many liter? 1 millimeter 0.001 liter, 1 centiliter 0.01 liter, 1 centiliter 0.01 liter, 1 kiloliter 1000 liter, 1 kiloliter 1000 liter, 1 cubic foot 28.316, 1 millimeter 0.001 meter. So 1 centimeter 0.01 metric. So 1 km 1000 meter, 1 inch 25.4 mm, 1 foot 0.3048 m, 1 mile 1.693 meter, 1 feet 12 inch, 1 yard 3 feet. So 1 acre 4840 1 hectare 2.47 acre, 1 milligram 0.00 gram, 1 kg 100 gram, 1000 gram 1 kg. So measurement, so it is found by measuring measurement. It is found by measuring measurement. It is found by measuring, or it is process or unknown quantity with a known or standard quantity like size, shape. So inspection, it is the checking of the product from raw material to finished product. It is the checking of the product from raw material to finished product. So what is basic value? What is basic value? The size of the part specified in the drawing. What is basic value? The size of the part specified in the drawing. That is the basic value. The size of the part specified in the drawing, that is the basic value. Actual value, before measuring the size, actual measure dimension of the part. After manufacturing, what you get, that is called actual value. Before manufacturing, the actual size, measure dimension of the part. After measuring, what you will get, that is the actual value. Accuracy, it is the nearest or closest of the basic value. It is the nearest or closest of the basic value, or how close a measured value is to the true value, how close a measured value is to the true value. Precision, it is how close to measure value are to each other. It is the repeatability of the measuring process. So error, So it is the difference between actual size. It is the difference between actual size and the basic size. This is the error. It is the difference between actual size and basic size. That is called error. Types of error. There are seven types of so many types of error are there. So common errors are instrumental error, environmental error, human error, job setting error, machine error, parameter error. So calibration. So calibration in practice. So in practice, calibration also include repair of the device if it is out of the calibration. So it is in practice, calibration also include repair of the device if it is the out of the calibration. Suppose any instrument show any wrongly, then it is you can calibrate it, or it is a comparison between it. So or it is a comparison between a known measurement and the measuring using your instrument is called calibration. It means make something error free. Standard. What is standard? Standard is a standard is defined as something that is set up, and a standard is defined something that is set up and established by an authority as the rule of measure of quantity, as the rule of measure of quantity, weight, extent, value or quality. So example, meter is a standard established by a industrial organization for measuring of the length. That is called standard. Meter is a standard established by an industrial organization for measuring the length. That is called standard. So types of standard. So there are different types of standards are there. So based on the measuring method, first one is primary standard or a reference standard. So these are the material standard. So what is primary standard? These are the material standard measure under most careful condition. So these are not used to directly for measurement, but they are used once. But they are used once. 10 years for the calibrating secondary standard. So example, it should have a high degree of purity in 99.98%. That is the primary standard. So what is secondary standard? Any error existing in the primary standard after long internal are used, then go to the secondary standard. These are also safeguard against the loss or destruction of primary standard. What is tertiary standard? Tertiary standard or inspection standard. Primary and secondary standard exist in instrument. Primary and secondary standard exist instrument used in tertiary standard. For example, these instruments are make it. Those are employed. So those are employed by National Physical Laboratory and made as closed copy of standard. So working or worksheet standard. So these are similar in design to primary, secondary, and tertiary. So these are similar to design to primary, secondary standard. So you bring less in the cost and made low degree materials used for the application in the metrology lab. That is the working standard. And another one is line standard. So types of standard. Another one is line standard. So type is based on the measuring method. So line standard. So when the length is measured and the expressed as a distance between two lines is called line method. What is line method? When the length is measured and expressed in distance between two lines is called line method. Measuring scale, international protometer, that is called end standard. When the length is being measured and the expressed as distance between two parallel places is called end standard. So Vernier Caliper, micrometer, that is called end standard. So wavelength standard. So using as the length is the basic unit or primary standard. That is called equivalent standard method of measurement. So measuring instrument can be classified as two types. One is direct method, one is indirect method. So direct, steel rule, Vernier caliper, micrometer, that is called direct method. And its indirect method, we require a reference or any mathematical formula for taking reading. So divider, caliper, sine wave, that is called indirect measurement. What is contact? What is contact? CMM. So coordinated measuring machine or surface roughness tester. That is contact. So coincidence. So what is coincidence? OPP. Optical profile projector. Optical profile projector. That is coincidence. Precision. Vernier caliper micrometer. No precision. Divider caliper scale. Classification of measuring instrument. Engineering methodology is purely measure of the physical quantity. So linear measuring instrument, angular measuring instrument, instrument for checking geometrical for surface roughness. So limit, weight and tolerance. So important terminology. So it is the size in lamely only which is identified and the nominal size may not match any dimension of the product. It is a highly standard dimension tolerance. Example, half basic size. So it is a size of the job. It is a size of the job in relation to which all limits variation are determined in the same both whole and shaft. That is basic size. Zero line. The zero line is called basic line. A whole. So it is a term used to designate all internal picture of parts, including those which are not cylindrical. That is whole. Whole. Shaft. It is a term used to designate all external feature of the part, all internal feature, that is a whole, all external feature of the part, including those who are not cylindrical. So that is shaft. Deviation. It is the algebraic difference between actual size of the job and basic size of the job. So mathematically, deviation equal to actual size minus basic size. So measure deviation minus theoretical deviation. Lower deviation. This is the difference between mean limit and basic size of component. This is the difference between mean limit and basic size of component. Upper deviation. It is the difference between max limit and basic size of component. Basic shaft. It is the shaft whole upper deviation is 0, or where maximum limit size is equal to the basic size. Basic hole. It is a hole whose lower deviation is 0. Basic shaft. It is shaft whose upper deviation is 0 and where the maximum size is equal to the basic size. Basic hole. It is the hole lower deviation is 0 or when minimum or limit size is equal to the basic size. Tolerance. It is defined as the difference between maximum limit and minimum limit of the hole or shaft. See that image, you can understand about the limit and tolerance. So that is the image you can understand, that is hole and that is shaft, and this is the tolerance, and this is the maximum dia, this is the mean dia, the hole and shaft. So tolerance upper limit minus lower limit, that is called tolerance. Upper limit minus lower limit. So upper limit, so 25 plus 2, lower limit minus 0.2. Tolerance 25 minus 24.0.4 mm. Means C, that is the tolerance. So what is upper limit and lower limit together? So it is divided into three types. So tolerance, it is divided into three types. One is unilateral tolerance, one is unilateral tolerance, another is bilateral tolerance, another is geometric tolerance. So what is unilateral tolerance? What is unilateral tolerance? So what is unilateral tolerance? So target deviation is given. Target deviation is given with a tolerance, and the variation only in one direction is called unilateral tolerance, because the size may only deviate in one direction. Example: 25 plus 0.02 plus 0.01. So 25 minus 0.02 minus 0.0. 25 plus 00 plus 00 minus plus 0.0 minus 0.0. Example, that is called unilateral tolerance. Then what is bilateral tolerance? When the two limit deviation is above and below nominal size, then the tolerance is bilateral tolerance. So 25 plus or minus 0.02, that is called bilateral tolerance. 25 plus 0.02 minus 0.01. So that is the base size, and that one is the tolerance. So you can, what is geometrical tolerance? So it is the system that allows unilateral, bilateral. You understand? Another one is geometrical tolerance. It is a system that allow tolerance to apply to picture rather than dimension or engineering drawing or CAD model. That is called geometrical tolerance. So flatness, straightness, cylindricity. That is the geometrical tolerance. So see that image, you can clearly understand about that tolerance. So how to find what is limits? What is limits? So what is limit? What is limit? The maximum and minimum permissible size, which is the actual size of a component, is called a limit. The maximum and minimum permissible size, which is the actual size of the component, is called a limit. So 25 plus 0.2 minus 0.2. So plus 0.2 minus 0.2 upper limit, plus 0.2 lower limit minus 0.4. This is that is called limits. That is called limits. Plus or minus, that is called limits. So what is speed? So it is defined as a degree of looseness. What is speed? It is defined as a degree of looseness and tightness between two melting parts. So perform definite function when they are assembled together, or when they are assembled together, or it is the clearance between two melting parts. That is called speed. Again, it is defined as the degree of looseness and tightness between two melting parts. So perform definite function when they are assembled together. So it is clearance between two melting parts. So types of feed. So clearance feed, there are different types of feeds here. There. First one is clearance feed. So whole clearance between hole greater than sap. So means maximum clearance, minimum clearance. So clearance speed, maximum clearance, minimum clearance. Hole is greater than sap. So another one is the interference speed, maximum interference, minimum interference. Hole is less than shaft. 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 So another one is the transition speed. Another one is transition, maximum clearance, minimum interference. Hole equal to shaft. Hole equal to shaft. That is called transition speed. So let's discussion about the clearance speed. So what is clearance speed? In clearance speed, an airspace or clearance exists between the shaft and hole. Such speed is loose speed. So in the clearance speed, an airspace or clearance exists between. So in airspace or clearance exists between shaft and hole. The such speed is called loose speed or clearance speed. So tolerance zone never met. Tolerance zone never met. So tolerance zone as the whole will be above range zone of the shaft. So that is called clearance speed. So maximum clearance hole and shaft. See that the image you can clearly understand. So maximum clearance, minimum clearance, lower limit of hole minus upper limit of shaft. Maximum clearance, lower limit of hole minus lower limit of shaft. In clearance speed, the difference between the minimum size in clearance speed, the difference between the minimum size of the hole and the maximum size of the shaft is called minimum clearance. The difference between the maximum size of the hole and minimum size of the shaft is called maximum clearance. The clearance speed may be clearance speed may be slide clearance speed may be slide speed, easy sliding speed, running speed, slack running speed, and losing speed. Another one is interference speed. Another one is second one is interference speed. So an interference speed also known as press speed or friction speed. An interference phase is also known as press speed or friction speed. So it is a form of fasting between two tightening metal parts that products joints, which is held together by friction after the parts are pushed together. So in interference speed, the difference between in interference speed, the difference between shaft is maximum size and the hole is minimum size. So that the maximum interference, the difference between the shaft minimum size and hole maximum size is minimum clearance. So the interference may be shrink speed, the interference may be shrink speed and heavy drip speed and light drip speed. So that is the interference speed. That is interference speed. See that. And then another is what is transition speed. What is transition speed? The transition speed is a speed which may provide either clearance or interference. In the transition speed, may tolerance zone of the hole and shaft overlap with each other. That is called transition. That is called transition speed. So the transition speed may lies between clearance and interference. So this speed may be force speed, this speed may be force speed, tight speed, or push speed. That is called transition speed. So hole and shaft basis system. So hole and shaft basis system. So we can read about that or see that image, that is hole and shaft basis system. Hole basis system. So when the hole is contact and shaft is changed to obtain various types of feed called hole basis system indicated by H. So lower deviation is zero. Indicated by H. So lower deviation is zero. That is clearance, shaft 1, shaft 2, shaft 3. That is hole basis system. That is hole basis system. Another one is shaft basis system. So same whole basis system is preferable. Whole basis system is preferable because whole produced by standard size tool like drill, ribbons, and beam, etc. But shaft are manufactured rolling, casting, then the finish turning and the grinding. Shaft basis system. When the shaft is constant and the hole is very bad, to get various types of feed called shaft basis system. It indicates small edge. Basic size of shaft is taken as maximum limit of the shaft. Shaft basis system is prepared for long shaft full length. Clearance speed, transition speed, interference speeds. So that is the shaft basis system. Allowance. What is allowance? The maximum shaft size and minimum hole size is called allowance. Maximum shaft size and minimum hole size, that is called allowance. In clearance speed, allowance is positive. In interference speed, allowance is negative. In clearance speed, allowance is positive. In interference speed, allowance is negative. So clearance speed dia 10 H7 G6, interference speed H7 P6, transition speed H7 K6. So dia 10 is the basic size. So H and G is bounded by deviation. 7 and 6 is fundamental tolerance. So whole node. Whole always capital letter A to Z, shaft small letter A to Z. Note basic shaft. Note basic shaft you can do. It is a shaft whose upper deviation is zero. Basic hole. It is a hole whose lower deviation is zero. So according to the hole and shaft basis system, we can calculate the type of feed using formula. Upper limit hole minus lower limit shaft, lower limit hole minus upper limit shaft. So in both becomes the positive, then the feed is clearance. If both becomes positive, the feed is clearance feed. If both value becomes negative, that is interference feed. If both become positive and negative, that is transition feed. That is transition feed. That is transition feed. So this is my part 1 video. Let's discuss about in part 2 video. So that one you clearly understand in everything. So this is my part 2 video, and in this video I will discuss about that universal bevel protector. Universal bevel protector. So what is universal bevel protector? See that image, you can clearly understand about that. Universal bevel protector or Vernier bevel protector. That one 66 degree. So 1 second, I will inform that. So first this is a angle measurement. So this is part 2 video in main motive is angle measurement. Angle measurement. So in angle measurement, you can see that is the different types of image are there. Which type of angular measurement? So let's say discussion about there are three types of, one is a linear, one is angular, another one is a perpendicular. So what is a linear type of angular measurements are there? So you can see that image. So angular measurement, one is angle protector, another is a Vernier bevel protector, another one is a sine wave. So angle protector. In a angle protector, reading is a degree unit. Here is the only one scale, so do not need to calculate the least count. Angle protector is used to measure the angle between two faces of the component with the accuracy of 1 degree. Then another one is universal bevel protector or Vernier bevel angle protector. So see that image, that is the Vernier bevel angle protector. So uses used to measure the angle between two surfaces of a component with the accuracy of 5 minutes. Specification: length of the blade attached, mechanism bevel action, least count 5 minutes. So calculation of the least count. So least count is smaller deviation of the main scale divided by total number of sub-scale division. So 1 degree equal to 12. So 1 degree 60 minutes. So 60 minutes divided by 12. So equal to 5 minutes. See that image. Way of measuring accurate angle using a bevel angle protector. Way of measuring obtuse angle using bevel angle protector. Then that one is the 30 minutes 85 degree. So reading formula, main scale reading. So Vernier scale coincidence into least count. What is the formula? Main scale reading, one main scale reading plus Vernier scale coincidence into least count. That is the reading formula. So 30 degree, 30 minutes, 85 degree. Then so this one is the 66 degree. Then this one you can see that is the image. You told that in which degree, how much minute. So this one is 32 degree 30 minutes. This one is 32 degree 30 minutes. So another one is sine wave. See that is the picture, you can read and understand about that what is sine wave. So the two parallel roller must have equal diameter and by two cylinder. So the roller must be set parallel to each other and the upper of the faces. The precise center distance between the roller must know. The upper face must have a high degree of flatness. So sine bar is used to measure angle and locating anywhere to given angle with the help of slip gauge bar, and a dial gauge of the spirit level dial gauge of the spirit level principle of the sign bar is based on trigonometrical function. Sign bar, see that is the sign bar. How to measure? You will explain that. Then sign bar, sin theta equal to p by h or perpendicular by hypotenuse. See that the measurement of the upper angle using sign bar. See that is the sign bar. How to check in sign bar? So checking for unknown angle for heavy component. How to check? We will mention that. So this is my part 2 video, part 3 video. So you can read and understand about the sign bar. So let's discuss with another topic. So in that video, I will discuss about that limit and feed. So you can understand about what is so what is limit and feed. So what is limits and feed? So limit, before limit and feed, you understand. So first, what is production, mass production? It means production of a unit or component or part in large number. It is production of large amount of standard product in a constant flow. That is called mass production. So advantages of the mass production. Advantage: high rate of production with reduced cycle time, higher capacity utilization due to the linear balancing, less skill operation are required, low process inventory, manufacturing cost per unit is low, limitation or disadvantages. Breakdown of the machine will be step by the entire production line. Line layout needs major changes with the changes in the product design, high investment in production facility. The cycle time is determined by the slowest operation. Interchangeability. What is interchangeability? An interchangeable part is one of the which can be substituted for similar part manufactured to the same drawing. That is interchangeability. So when one component assembled properly and properly with any mating component both chosen at random, then it is known as interchangeability. Or the parts manufactured under similar condition by any company or industry at any corner of the world can be interchangeable. Interchangeability of parts are achieved by combining a number of innovation and improvement in machining operation so that will produce component with accuracy. In modern machine tools look like numerical control or CNC, the involve jigs and fixture. So gauges to check the accuracy of the finished parts. This helps in manufacturing components with specified limits. Selectivity assembly. So you can read about this all these things. You can then the interchangeable, what is interchangeable, you can understand about that. Then tolerance. So tolerance is defined as the total permissible variable of size. It is difference between the maximum limit and minimum limit of the size. So classification of tolerance. One is dimensional, one is geometrical. The total amount by which a specified dimension is permitted by permitted to vary. So allowance. It is the difference between the basic dimension of the mating parts. When the shaft is less than the hole size, then the allowance is positive. When the shaft is greater than the hole size, then the allowance is negative. So tolerance. So it is the difference between the upper limit and lower limit of a dimension. You can see that image, then you can clearly understand about that. Then size. It is the number expressed in a particular unit, the measurement of length, that is size, actual size. Actual size, actual measured dimension of the part after manufacturing. Basic size, the size with reference know which the limit size are fixed, that is the basic size are fixed. Zero line, it is a straight line corresponding to the basic size. Zero line, it is the straight line corresponding to the basic size. The deviation are measured from the line. The positive and negative deviation are shown above the below zero line respectively. So limits of size. The two extreme permissible size of a part between which the actuals should be the lie. That is the limit of size. So maximum limit of size, the greater of the two line of the size. Minimum limit size, the smaller of the two line of the size. Shaft. A term used by convention to designated all external feature of the part, including those who are not cylindrical. Hole. A term used by convention to designate all internal feature of the part, including those who are not cylindrical. Deviation. The algebraic difference between a size, actual or maximum, etc., and corresponding to basic size. Actual deviation. The algebraic difference between the actual size and corresponding basic size. That is actual deviation. Tolerance zone. It is a tolerance zone. Tolerance zone. It is a zone between maximum and minimum. It is the zone between maximum and minimum limit size. Upper deviation. It is the algebraic difference between maximum size and basic size. The upper deviation of a whole. The upper deviation. The upper deviation of whole. The upper deviation of whole is represented by symbol ES. Restar superior, and the shaft is represented by ES. Means our upper deviation capital, smaller deviation shaft. Then lower deviation. It is algebraic difference between minimum and basic size. The lower deviation of whole is represented by a symbol and the shaft is represented by this symbol. See that image, then you can clearly understand about that. What is unilateral tolerance? In this system, the dimension of part is allowed to vary only one side of the basic size. So that is the tolerance lie only on the side of the basic size, either above or below it. Bilateral tolerance. In the system, the dimension of the part is allowed to vary on the both side of the basic size. That is, limit of tolerance lie either side or basic size. Then allowance. It is an external difference between the maximum material limit of mating pads. For shaft, the maximum material will be its high limit, and for hole, it will low limit. It is the minimum clearance. It is the minimum clearance or maximum clear interference. It is the international difference between basic dimensions of mating pad. These allowance may be positive or negative. So feet. A feet may be defined as the degree of tightness and looseness between two mating pads. So feet, there are three types of feet are there. One is clearance, another is transition, another is interference. So clearance feet. In clearance feet, an airspace or clearance exists between the shaft and hole. That is called clearance feet. Such feet, loose feet, loose joints. A clearance feet are positive allowance. That is, there is a minimum positive clearance between high limit of the shaft and lower limit of the hole. So allow rotation or slide in between the mating parts. See that the image, you can clearly understand about that. And types of clearance feet, loose feet. So it is used between two mating parts where no precision is required. It provides minimum allowance and it is used loose pulley agricultural machinery. Running feet. For running feet, the dimension of shaft should be smaller enough. Maintain a film of oil from lubrication. It is used in bearing pairs, etc. Slide feet or medium feet. It is used for those mating parts where greater precision is required. It provides medium allowance and it is used to tool slide valve, automobile parts. Interference feet. A negative difference between diameter of hole and the shaft is called interference. In such cases, the diameter of shaft is always greater than the hole diameter. It is used for component where motion power has to be transmitted. So interference clearance hole minus shaft minus shaft. Interference exists between a high limit of hole and lower limit of shaft. And types of interference feed. Stream feed or heavy force feed. It refers to the maximum negative allowance in assembly of hole and the shaft The hole is expanded by heating, then the rapidly cool its position. It is used in the fitting of the rim, etc. Medium force feed. These feeds have medium negative valence. Considerable pressure is required to assembly to hole and the shaft. It is used for car wheel, armature, dynamo, etc. Tight feed or force feed. So one part can be assembled into other with a hand rammer and a light pressure. A slight negative valence exists between two mating parts more than ringing feed. So it gives the semi-permanent feed are used to keep pulley, shaft, rocker, arm, etc. Transition feed. It may result either clearance speed or interference speed, depend on the actual value of individual tolerance mating component. Transition feet are compromise between clearance and interference feet. These are used for applications where accurate location is important, but either small amount of clearance or interference is permissible. Types of transition feed. Push feed or snap feed. It refers to zero valence and a lighter pressure is required in assemble the hole and the shaft. The moving parts show least vibration with type of feed. Force feed or shrink feed. A force feed is used when two mating parts have to be rapidly fixed so that the one cannot move with the other. It either requires high pressure force the shaft into the hole and the hole expanded by heating. It is used railway wheel as rigging feed. A slight negative valence exists between two mating parts in the ringing feed. It requires pressure force shaft into hole and give a light assembly. It is used in fixing key pin, etc. So feed, detailed classification of feeds, clearance, transition, interference. So clearance, slide, easy to slide, running, slack running, loose, push or snap, ringing for the transition, interference, force or press, driving, tight, shrink, freeze. Hole and shaft basis system. So hole basis system, size of the hole is kept constant. The shaft is varied to the different feeds. So shaft basis system, so shaft size of the shaft is kept constant, and hole size is very varied to get different feeds. So surface roughness, RML. Surface roughness is a measure of the texture of a surface. It is qualified by the vertical deviation of a real surface from its ideal form. If it is deviation are great, the surface is rough. If they are small, the surface is smooth. So necessity of the quality. So quality control QC for short is the important part of every production process. In QC, the product is checked against the specification and the decision to continue is made accordingly. So quality control of surface roughness is essential part of process like cleaning, coating, and printing to determine if the applied process has been successful. See that image, you can clearly understand about that what is surface roughness. So this is my part 3 or part 4 video. So let's discussion about that another topic. Then you can clearly understand about that in my. So this is the another limit fit and tolerance in gauges. See that image, then you can clearly understand about that what is limit, tolerance, and gauges. So limit. So two extremely permissible size for any dimension, two extremely permissible size for any dimension or permissible size range of variation in dimension from the basic size, that is called limits. The difference between those two limits is called permissible tolerance. In other words, the magnitude is permissible variation of dimension is tolerance. When the tolerance disturbance is only one side of the basic size, is referred as the unilateral tolerance. If the permissible variation is both plus or minus, it is referred as a bilateral tolerance. So see that image, that is the unilateral tolerance 20 plus 003 or minus nothing, 20 bilateral 20 plus 003 minus 0.2, that is bilateral tolerance. Feed. What is feed? When two parts are to assemble and the relation resulting from difference between their sizes before assembly. So depend upon the actual limits of the hole and shaft may be classified as So clearance speed, interference speed, and transition speed. Clearance speed. So minimum deviation of hole is greater than the maximum deviation of shaft. That is called clearance speed. Interference speed. So minimum deviation of shaft is greater than the maximum deviation of hole. That is called interference speed. Transition speed. Minimum deviation of hole is greater than the minimum deviation of shaft, but the maximum deviation of a shaft is greater than the minimum deviation of hole. That is called transition speed. So that the different types of speeds are there. This is first one is clearance speed, second one is interference speed, third one is transition speed. See that image, then you can clearly understand about that allowance. The maximum shaft size and minimum hole size is called allowance. Maximum shaft size and minimum hole size is called allowance. In clearance speed, allowance is positive. In interference speed, allowance is negative. See the example of clearance speed dia H7G6. Example of interference speed 10H7P6. And example of transition speed 10H7K6. So these dia and 7 all are acceptable rotation in the hole and shaft. So dia 10 is basic size, H and small g is grade of the fundamental deviation, 7 and 6 is grade of the fundamental tolerance. So according to the ISI 919, so 1919 for the system limit and feed, grade of the fundamental deviation and grade of fundamental tolerance. So 28 and 20 is represently. So fundamental deviation of hole. So this is a theorem. Fundamental deviation of shaft, hole and shaft. So fundamental deviation. What is fundamental deviation? This is the deviation either upper or lower, which is nearest to one of the zero line, either hole or a shaft. It fixes the position of the tolerance zone in relation to the zero line. A design English alphabet letter, the capital letter used for the hole deviation and small letter shaft is given the shaft. So all hole A, B, C, D, H, Z, that is a hole shaft with zero line. This is the line which represented. This is the line which represents the basic size of the deviation from the basic size is 0. This is the line which represents the basic size so that the deviation from the basic size is 0. And grade of fundamental tolerance. This is a group of tolerance considered as corresponding to the same level accuracy for all basic size. It is in letter IT followed by such as I. So limit deviation for hole. Basic size is 0.3. Limit deviation for shaft. This is the shaft. See that. So commonly used feed hole basic system. Commonly used feed in hole basic system. So clearance feed A to H. Transition feed is to L. Interference feed. It is commonly used for the feed times basic system hole. So clearance feed A to H. Transition feed I J to N. Interference feed is. So basic shaft. So basic shaft is a shaft whose upper deviation is 0. Basic hole is a hole whose lower deviation is 0. According to the hole basis system and the shaft basis system, we can calculate the types of feeds using formula. So upper limit of hole minus lower limit of shaft. Upper limit of hole minus lower limit of shaft. Upper limit of shaft. In both value becomes positive, then the feed is clearance. If both value becomes negative, then the feed is interference. If both value becomes positive and negative, then the feed is transition. And gauges. There are inspected tools of rigid design without a scale, which reserve the check dimension manufacturer can. Gauge do not indicate the actual. Oh, 1 second. Gauges. So these are inspected tool of rigid design without a scale, which sought to check the dimension of manufactured part. Gauge do not indicate the actual value of the inspected dimension on the work. So according to their types of gauges are classified into One is the limit gauge, another one is the standard gauge. So there are two types of gauges. One is the limit gauge, another one is the standard gauge. What is limit gauge? So limit gauge is a gauge which is used to determine as whether the inspected parts are made within the specific limit. Is provided with two ends. One end is maximum limit, another one is minimum limit. That is limit gauge. Standard gauge. Standard gauge is a gauge which is used to check the standard dimension. It is made as an exact copy of mating part of the component to be checked. So a scientist called Frederick Window Taylor gave some principle of the gauge design. According to the Taylor principle, limit gauge have two ends. Limit gauge have two ends. One is go end, another one is no go. So go indicate the maximum material condition, no go indicate the least material condition. So and go side used for checking all elements and on the and one time and at the time, but no go used only for confirm, not dimension. Confirm the dimension, only no go used only for confirm the dimension. See that image, you can clearly understand about that. So plug gauge. It is used to check the whole dimension. What is plug gauge? Plug gauge, it is used to check the whole dimension. It is used to check the whole dimension. Threaded plug gauge. It is used to check the internal thread dimension. It is used to check the internal thread dimension. Ring gauge. By using the ring gauge, we can check the uniform and threaded shaft dimension. It is used to check the outside or uniform and threaded shaft dimension. This is the ring gauge. Snap gauge. It is used to check the shaft dimension. It is used to check the shaft dimension or cylindrical part type. This is different of single-ended snap gauge, double-ended snap gauge, single-ended snap gauge. So standard gauges. So standard gauges are there. So see that screw pitch gauge. It is used to check the pitch of the standard thread. It is used to check the pitch of the standard thread. Radius or fillet gauge. It is used to check the concave and convex radius. It is used radius gauge or fillet gauge. It is used to check the concave and convex of the concave and convex radius. Thriller gauge. It is used to check the clearance of the gap between the two assembly parts. It is used to check the clearance of gap between two assembly parts. Wire gauge. It is used to check the wire diameter and thickness of sheet by inserting the component in the notches provided. So that is the wire gauge. Drill gauge. It is used to check the lip angle. It is used to check the lip angle of the drill and measure length of the cutting edge. It is normally used after a drill as resharpened. Center gauge. It is used as a standard comparison of the threading tools and used for setting the tool in the tool post of the length of the center of the line B. So pointer represents a perpendicular to the axis of the rotating of the screw block and also testing a fluid angle of the length center. Telescopic gauge. It is used to check the dimension of hole and slot during machine operation. It is used to check the dimension of hole and slot of the machining operation. Slip gauge. It is used checking the linear dimension, calibration of measuring instrument and machine, and checking taper angle with sine wire. Slip gauge are designated 5 grades. In slip gauge are designated in 5 grades. Grade 2 used in software used in workshop. Grade 1 used for more precise work. Grade 0 used in inspection. Grade 00 used for high precision work in standard tool room. Calibration grade used to calibrate the standard dimension. So expect the calibration grade. Expect the calibration grade. All slip gauges set are manufactured with a specific limit. For reference gauges, grade 00 or 4 micron meter deviation is allowed working gauge or 8 micron per meter. So under the calibration grade, following sets are available in each and metric unit. For inspection standard grade 0 slip gauge are available in three sets such as M45 slip gauges are slip gauge. Slip gauges are available in three grades M45, M46, M112. See that is the image. So M222 set slip gauge. So ringing effect. What is ringing effect? The term ringing refers to the condition of an intimate or completely contact or permanent adhesion without any application of pressure between two clear, good standard or flat smoothness surface by sliding or the twisting. Until the block of the slip gauge are lined up, keep sliding and twisting the super finishing surface. There the air is filled between the gauges and they get a adder. This adder is called ringing effect. The gauge can be hanging in shown in the figure. So this is my part 5 video. So let's you can understand. I think you clearly understand that video. So let's discussion about my part 6 video, and that video you can clearly understand about that linear measuring instrument. What is linear measuring instrument? So let's start. What is my linear measuring instrument? So what is linear measuring instrument? What is linear measuring instrument? Let's start about this topic. Linear measuring instrument in commonly used. Linear measuring instrument commonly used. Caliper, steel rule, vernier caliper. Vernier caliper in so many types of vernier calipers are there. Dial vernier caliper, digital vernier caliper, vernier height gauge, depth vernier gauge, so groove vernier gauge, gear tooth vernier gauge. Then another one is micrometer. Outside micrometer, inside micrometer. Caliper. See that is inside caliper. Another one is orderly caliper. Another one is outside caliper. Another one is divider caliper. So two inside caliper, orderly caliper, two outside caliper, a pair of divider. Inside caliper are used to measure the internal size of the object. Outside caliper are used to measure the external size of the object. Divider caliper are used in the process of marking out stable workpieces, more specifically in the metalworking field. Orderly caliper generally used to scribe a line a set distance from edge of workpiece. The bent leg is used to run along the workpiece edge. Steel rule. What is steel rule? What is steel rule? Steel rule. It is a line measuring device. By the help of the instrument, we can measure linear dimension within accuracy of 0.5 mm. Material stainless steel. Specification maximum length that can be measured. So 0 to 150. So 0 to 300 mm and so on. And least count. So least count equal to 0.5 mm, generally 1 mm. So least count, the smallest measurement which can be taken by an instrument is called a least count of the instrument. Vernier caliper. See that is the vernier caliper. That is vernier caliper. See that image. Then what is vernier caliper? Uses. It is used for measuring external, internal, and depth of the blind hole. Mechanism. Sliding mechanism. Material. Stainless steel and enamel steel. Specification. Maximum length which can be measured range 0 to 150, 0 to 300 mm. Least count 0.02 mm, generally 20 micron. So least count equal to 1 main scale division minus 1 vernier scale division. So in neutral condition, 49 main scale division is coincided with the 50 vernier scale division. So 50 vernier scale division equal to 49 main scale division. So 1 main scale division equal to 49 by 50 main scale division. So least count equal to 1 mm minus 49 by 50 mm. So unit meter per second in mm. So 0.02 mm. So reading formula, main scale reading plus vernier scale coincidence into least count. Vernier caliper. Here is the main scale 37 and vernier coincidence is 23. So here is the here final reading is main scale reading plus vernier scale into least count. So 37 plus 23 into 0.02. So 37.46 mm. So here main scale is what is, you can tell me. So final reading is 34.6 mm. Then dial vernier caliper. Generally, structure of the dial vernier caliper like this. So uses. It is used for measuring. It is used for measuring the external dimension, internal dimension, and depth of the blind hole. It is used for measuring external dimension, internal dimension, and depth of the blind holes. So, dial vernier caliper mechanism, rack and pinion mechanism. Specification, least count and range. So 0 to 150 mm, 0 to 200 mm, 0 to 250 mm, and so on. So material stainless steel. Least count 0.01 mm general. So calculation of the least count, one main scale division divided by total number of subfield region. One main scale division 1 by 100 mm. So 0.01 mm. So reading formula, main scale reading plus pointer coincidence into least count. And dial vernier caliper, see that image. So here is the main scale is 24 and pointer coincidence is 35. So final reading is 24 mm plus 35 into 0.02. That one least count. So all over total is 24.70 mm. Then another one is digital vernier caliper. See that image, that is digital vernier caliper. So used to measure external internal dimension, used to measure external external dimension, internal dimension and depth. Mechanism, sliding mechanism. Least count 0.01 mm or 0.00 mm. Specification, range 0 to 150 mm, 0 to 300 mm and so on. Digital vernier caliper. Here the reading is directly displayed on the LED display. So reading is 9.95 mm. So then another one is a vernier height gauge. See that image, that is the vernier height gauge. So another one is depth vernier gauge. That is depth. The vernier height gauge. This is manual vernier height gauge, and another one is digital vernier height gauge is there. So depth vernier gauge. It is used for measuring depth of the large size hole and taper hole. It is used for the depth of the large size hole and taper hole. Mechanism, sliding mechanism. Material, stainless steel or enbar steel. Specification, range 0 to 150, 0 to 200 and so on mm. Least count 0.02 mm or 20 micron. Reading formula, same, main scale reading plus vernier coincidence into least count. Then groove vernier caliper. So groove vernier caliper, it is used for measuring internal groove or slot dimension. It is used for measuring for internal groove or slot dimension. Mechanism, sliding mechanism. Specification, range and dimension of measuring jaw. Range and dimension of measuring jaw. So least count is equal to 0.05 mm. So calculation of least count. So 2 main scale division minus 1 vernier scale division. 2 mm minus 39 by 20 mm. So the first division of vernier scale is close to the second division of main scale. 1 by 20 equal to 0.05 mm. Gear tooth vernier caliper. It is used to measure the width and height of the gear tooth simultaneously. Mechanism, sliding. Least count 0.02 mm. Specification range 0 to 25, 0 to 60, 0 to 80 mm. Vertical scale show the height and horizontal scale show the width of the gear. Then micrometer. So in micrometer there are different types of micrometer are there. First one is outside micrometer. So in outside micrometer, there are also different. One is a simple micrometer, one is the blade micrometer, another one is the screw thread micrometer, another tube micrometer. That is outside micrometer. So inside micrometer, 2-pin inside micrometer, 3-pin inside micrometer, 3-pin inside Vernier micrometer, depth micrometer. That is micrometer. You can see that in the micrometer. It is used for measuring the outside dimension, length, width, outer dimension, thickness of any profile. Mechanism, knot and screw mechanism. Material, anvil and spindle made of stainless steel, frame, cast iron, tip and anvil, spindle, tungsten carbide, rest of the parts inverse steel. Specification. Range of dimension 0 to 25 mm, 25 to 50 mm, and so on. Least count 0.01 mm generally, 10 micron. In calculation of the least count equal to 1 main scale division divided by total number of subscale division. So 0.5 divided by 50 mm, so 0.01 mm. Or least count equal to pitch divided by total number of thumb bell division, 0.5 divided by 50, 10 micron. In micrometer, pitch value is equal to lead value as having single start thread. So reading procedure, main scale reading plus thumb scale reading into least count. See, that is the micro. Here is the main scale reading 7 mm and thumb scale is 38 mm. So final reading is 7 mm plus 38 into 0.01 mm. So 7 all and overall is 7.38 mm. Here is the main scale and thumb scale you can told. So final reading is 7.72 mm. This one is the another micrometer. So this one is the digital micrometer. See how to micrometer read. So procedure to hold the micrometer. See that is the image. This one is the blade micrometer. So it is used for measuring. It is used for the measuring outside circular form, tool or diameter and depth of all types of narrow groove, slot, key slot, etc. accurately. So this type is very important. Blade micrometer, screw thread micrometer. It is used for measure the pitch diameter of screw thread. Mechanism, knot and screw. Mechanism, knot and screw. Specification, range and pitch thread. A list count 10 micron. So parts name and material which will be made as same simple micrometer. Tube micrometer. It is used for measuring the wall thickness of the tube and other parts with cylindrical walls. All features are same simple micrometer. 2-pin inside micrometer. See that image. That is the 2-pin inside micrometer. It is used to measure in 2-pin inside micrometer. It is used for measure the internal dimension like diameter, slot, etc. Mechanism, knot and screw mechanism. So left hand side. Specification range 5 to 30, 25 to 50 and so on mm. Material 2-pin tungsten carbide remaining inverse steel. Least count 10 micron. So least count equal to pitch divided by total number of thumbnail division. So 0.5 divided by 50, 10 micron. 0.01 mm. So 2-pin inside micrometer. Here is the main scale reading is 26 and the thumbnail scale is 38. So since the left hand side mechanism reading should be taken from the reverse direction. So final reading is 26 plus 31 into 0.01. So 26 by 31 mm. 3-pin inside micrometer. See that is the image. That is the 3-pin inside micrometer. So 3-pin inside micrometer is used for measuring the internal diameter. So mechanism, knot and screw, left hand side and taper screw. Material pin tungsten carbide, remaining parts are in steel. Least count, so 5 micron, 0.005 mm. Calculation of the least count, smallest division of the main scale divided by total number of thumbnail division. So 0.5 divided by 100. So 0.005 mm. 3-pin inside micrometer. Here is the main scale reading is 20 and the thumbnail scale is 28. So final reading is 20 plus 28 into 0.05, so 20.14 mm. 3 pin inside, 3 pin Vernier inside micrometer. 3 pin Vernier inside micrometer is using for measuring internal diameter. Mechanism knot and screw, left hand side. Specification range 10 to 12, 12 to 14, 14 to 15 mm. Least count 0.001 mm means 1 micron. Calculation at least count least count of ms and ts. So 0.5 divided by 50. So 10 micron. Final least count Vernier and micrometer 0.01 mm by divided by 10. So 0.001 mm. So reading formula main scale reading plus TS and LS plus BS and LC minus MSR plus TS into 0. Into plus 3 pin inside micrometer. See, that is the image. You can read and understand about this is the one example. Then depth micrometer. Depth micrometer. Depth micrometer. It is used for measuring. It is used for measuring the depth of the hole, slot, and recess area. Mechanism knot and screw. Material inverse steel body parts and stainless steel extender. Specification. So dimension of extension rod 0 to 25, 0 to 20 or 25 mm, 20 to 25 to 40 to 40 50 mm, and so on. So least count equal to 10 mm. Least count calculation 0.5 divided by 50 mm, 10 micron, 0.01 mm. Reading formula main scale reading plus thumbnail division into least count. Depth micrometer. Here is the main scale reading is 7 mm and thumbnail scale reading is 49. So final reading is 717 mm plus 49 into 0.01 mm equal to 17.47 mm. So thank you for watching this video, and this video is very helpful for everyone. So this is my part 6 video. So let's discuss about my part 7 video. And this is my part 7 video, and in that video I will discuss about marking and marking tools. Marking tools. So see that you can understand about that what is marking and marking tools. So definition. The most important step in marking machine part in particular fitting operation in marking layout guidelines on the metal before machining or cutting by hand tools. So purpose of marking to ensure that the correct amount of material is removed from the various spaces so that the correct shape is produced. To provide line which can be served as the guide indicating that the correct size has been reached. Marking media. A metal is hard, marked lines are shown clearly, so it is due to this reason that marking medium is applied in the metal layout. The different marking media are white wax and Prussian blue, copper sulfate and silver liquid. White wax performance. Methods of marking: Raccoon line method, center line method, marking by template, marking or center round end. So this is the Vernier height gauge, surface gauge, Vernier Caliper, center gauge. Equipment and instrument: surface plate, marking of table, scriber, divider, trumbull, punch, surface gauge, V-block, angle plate, square box, parallels, bevel square, combination set. This is the surface plate. This is the surface plate. You can read it about that in fully details about the surface plate. This is the surface plate. This is the mark of table. This is the mark of table. You can read, see, you can watch this video and watch this image. You can clearly understand about this marking of table. This one the scriber. I think previous video I have discussed about that scriber, and you can read that image and see that image. Then you can clearly understand about the scriber. This is the divider. This is the divider. You can read and understand about this topic. This is the trimble. What is trimble? So trimble are used to draw arc, circle and greater radius. Trimble point are attached to the bar of the length to speed up the job. This is the Vernier Caliper. You can see that is the Vernier Caliper. This is the punch. So this is the punch. Many types of punch are used in the workshop. So you can see and read about this which type of punch are required. You can use it. This is the center punch. This is the prick punch. Then different types of punch are there. So you can use it in your whatever your requirement. Surface gauge. This is the surface gauge. You can read and write and inspect it yourself. So uses of the surface gauge. So types of the surface gauge, one is the fixed type, another one is the universal type. So the fixed type of surface gauge consists of heavy flat base and spindle fixed upright to which are scriber attached with the snout and clamp thinner. Universal type, there are different types of slug gauge are there. You can read and write about this topic. Another one is B block. So you can see that is the image of the B block. You can write and understand and read about that image and understand about this line. Then you can clearly understand. Then types of B block, there are the single-ended type, double-ended type. Then different types of V blocks are there. You can see that is the V block. It's the angle plate. So in angle plate, you can read about that image or size, then you can clearly understand of the angle plate. The specification of the angle plate. There are different types of angle plates are there. Plane side, solid angle plate, slotted type angle plate, swivel type angle plate, box angle plate, square box. The box square is used to draw lines on the surface of the round stock parallel to the axis, such as when the setting out keyway and splines. Parallels. This is the parallels. This is the bevel square. The combination set. Protractor, square head, and center head. This is the combination set. So, so this is my part 7 video. You can, I think, you can understand about this video. So let's discussion about my part 8 video. So that video, I think clearly. And this is my part 8 video, measuring and measuring tools. So this one also one important tools in measuring and measuring tools. That one also same type before video. So you can just read that definition of the determine the size of the component in terms of standard unit is called measurement. Determine the size of the component in terms of standard unit is called measurement. For example, linear measurement applies to measurement of length, diameter, height, thickness, etc., covering both the internal and external features. So types of measuring tool, one is the fixed type. So there are different types of measuring tools are there. One is the fixed type. Fixed type means steel rule, plug gauge, filler gauge, that is the fixed type. Another one is adjustable type. Caliper, surface gauge, micrometer, that is adjustable type. One is the direct reading. Steel rule, Vernier Caliper, micrometer, that is the direct reading. Another one is the indirect reading. Divider, caliper, surface gauge, that is the indirect reading. Non-reading. Snap gauge, plug gauge, ring gauge, that is the non-reading. So this is the steel rule. So we can read about that steel rule, how do the least count, how much length. You can read that video or image. So this is the type of steel rule. You can read that these are the types of steel rule. So engineering rule, folding rule, flexible rule, hook rule, slot rule, shrink rule. So hook rule, you can read and write about that. Hook rule and short rule, you can read about that. This is the shrink rule. See that image, you can read about that. This is the caliper. So caliper are simple indirect measuring instrument used to transfer measurement from a steel rule to object and vice versa. That is the caliper. There are different types of calipers are there. So we can read it. So for joint caliper, spring joint caliper. So this is a tri-square. You can read about that with tri-square. This is a very important equipment. This is the scriber. There are different types of scriber, and in scriber tri-square are used. There are different types of used in the tri-square. So this is the straight edge. So in that straight edge, there are different types of straight edge are there. You can read and write it. So this is my part 8 video. So thank you so much for watching this video, and let's discuss about my part 9 video, and this video also most important. And this is the precision instrument, and there are different types of precision instruments are there. So let's discussion about precision instrument. So precision instrument. Precision is how close the measured values are to each other. That is the precision. Precision is defined as the repeatability of measurement to consistently reproduced. That is the precision. So classification of measuring instrument. According to the function, the measuring instruments are classified as linear measurement, angular measurement, instrumental for checking the geometrical form, instrument for determining the quality surface finish. So types of measurement: linear measurement, angular measurement, geometrical measurement, surface roughness measurement. So linear measurement: steel rule, vernier caliper, vernier height gauge, micrometer. Vernier caliper. You can read about that Vernier caliper. What is Vernier caliper? A Vernier caliper is a precision measuring instrument used to measure linear measurement like outside, inside, depth of a component. So list count 0.02 mm or 20 micron. Specification 0 to 150, 200, 250, 300, 600. Mechanism sliding mechanism. Material inverse steel, stainless steel. Used for three types of measurement: internal, external, depth of the blind holes. See, that is the image you can measure and use it. So how to use it? One time you will calculate and how to use that Vernier caliper. So see that the image you will read and understand about that image. See, that is, and you will measure in one by one. Then is the outside micrometer. A micrometer is a precision instrument used to measure a job, generally with an accuracy of plus or minus 0.01 mm or 10 micron. Least count 0.01 mm or 10 micron. Specification 0 to 25, 50, 75, 100 mm. Mechanism: nut and bolt, material, frame or malleable cast iron, anvil, alloy steel, spindle, alloy steel, measuring pace, tungsten carbide. Types of micrometer. There are different types of micrometer in mainly outside micrometer, inside micrometer, depth micrometer. Outside micrometer, it is used to measure the external dimension like shaft diameter, thickness of plate, flat, etc. Inside micrometer, inside micrometer are used to obtain direct measurement of any internal sizes such as diap, hole, and this hole and this between two parallel surfaces. And depth micrometer. It is used to measure the depth of the hole, slot, projection, and recesses, QA, etc. This is the micrometer. You can see and use that micrometer, then you can understand about that. So vernier height gauge. It is the precision measuring instrument used to measure the height of the parts. So least count 0.02 mm or 20 micron. Mechanism sliding mechanism. Metal inverse steel, stainless steel. Specification: height of the beam. Types of height gauge: fixed vernier height gauge, adjustable vernier height gauge. So vernier depth gauge. A vernier depth gauge is a precision instrument used to measure the depth of the measurement of hole, recess, slot, steps with an accuracy of 0.02 mm. Dial test indicator. It is the high precision instrument used for comparing and determining the variation in the size of the component. This instrument does not give reading on sizes. So types of mechanism: lever type, lever or scroll type, another one is plumage type, rack and pinion type. Accuracy 10 micron, 0.01 mm. Uses it is compared dimension of the workpiece to check the plate surface of the parallelism and flatness, to check the straightness of the shafts and bar, to check the concentricity of bolts and shafts. So plunge type, this is the plunge type, and this is the lever type. Dial stand. So magnetic with universal clamp, magnetic with flexible post, general purpose holder with cast iron belt. So Vernier Bevel Protractor. So bevel protractor are the angular measuring device. Vernier bevel protractor is the simplest angular measuring device which is having a Vernier scale. Similar principle as the Vernier Caliper. So along with the acute angle attachment 1 division and least count equal 60 by 12 or 5 minutes. So this is the Vernier bevel protractor. Sine bar. A sine bar is used to measure the angle of the given specimen accurately. It is usually measure the angle of the specimen as well as the locate of the workspace properly to measure the angle of it. The name of the sine bar as in the picture becomes operation of the sine bar is completely based on the trigonometry. Sine theta is equal to opposite side by h, p by h. You can read and write about that and you see that image. And another is sleep gauge. So in that sleep gauge there are different types of grades are there. In previous PDF I will explain in the sleep gauge. You can read and understand about this sleep gauge. So that is my part 9 video, and that video also most important thing. Let's discuss about my part 10 video and that one also last my video. And in this part 10 video, I will discuss about that surface roughness. And what is surface roughness? You can see that is the image. Surface roughness. The irregularity of the surface occur or created by any machining process is known as surface roughness. So peak and valley created are after finishing machining operation. Two types of surfaces: ideal surface, no irregularity on the surface; actual surface, after manufacturing surface having irregularities. Term used for surface roughness measurement: roughness height, roughness width. You can read about this term, then you can clearly understand about that. So see, that is the image of the roughness. So roughness width of the cord, lay, roughness height, flaws. Why surface roughness is generated? Surface roughness generated due to improper parameter field, depth of cut, speed and a blunted tool. Measuring surface roughness. There are different types of measuring surface there. You can read about that. Yeah, analysis of the surface roughness. How to analyze of the surface roughness. And so roughness are also calculated by area. Then root mean square average, RQ square average. A surface roughness table. This is the surface roughness table. See, that is the image. Indication of the surface roughness. So see, that is the indication of the surface roughness. So surface roughness indication symbol. You can read and write about that. And this is the direction of the leg of the surface roughness. This is the direction of the leg of the surface roughness. So that's all about for me. So thank you for so much for watching this video, and this video is very helpful for quality and industrial engineering. Thank you.